When people imagine how we are going to solve global warming, they usually picture a futuristic megastructure rising out of the ocean. The tools necessary to solve global warming already exist today. This is an energy, land use, and industrial coordination problem that we can solve by burning much less fossil fuel while building a more efficient economy. This chart shows projected global energy investment for 2025. It reveals that clean energy is attracting roughly twice as much capital as fossil fuels, driving total clean energy investment to $3.3 trillion. We have the technology, and the capital is flowing. The primary obstacle holding us back is speed. It is grid bottlenecks, the pace of permitting, and political coordination. Overcoming this requires viewing the global economy as an interconnected machine. We don't need a single software patch. We need a step-by-step system upgrade. Electricity is the backbone of decarbonization. Cleaning the power grid first unlocks the ability to clean up daily human life. That means building massive amounts of solar and wind and keeping nuclear power running where it is safe and cost-effective. A massive chunk of our daily emissions comes entirely from infrastructure lock-in. People use what the system gives them. If a city requires driving, people drive. If homes are built for gas, people burn gas. They are following the default. Replacing those endpoints changes the default behavior. A heat pump, for example, easily beats a gas furnace by drawing ambient heat straight from the outside air, even in freezing weather. The same principle scales up to entire cities. When you electrify public transit, like these buses pulling power from overhead charging stations, you multiply the carbon savings across thousands of daily commutes. When the foundational grid is low carbon, and the vehicles and buildings rely on that electricity, society decarbonizes automatically. We do not have to rely on mass behavioral changes. If carbon dioxide is the long game, methane is the emergency brake. Methane gas warms the planet much more strongly in the short term, making it a high-impact multiplier for global temperatures. The biggest sources of this are not glamorous. They are oil and gas leaks, coal mining, landfills, and industrial flaring. According to the IEA, the International Energy Agency, the energy sector can stop 70% of its methane emissions from fossil fuel operations using technology we currently possess. Finding and fixing these leaks is one of the fastest, most cost-effective wins available to slow down global warming right now. Treating methane as a top-tier emergency curbs short-term temperature spikes. That buys the world the time it needs to finish upgrading the broader electrical grid. Industrial foundries operate at a scale that exceeds current battery limits. A massive molten metal crucible requires intense, sustained thermal energy that is physically difficult to provide through the wires of a standard grid. Steel and cement production are complex because they involve molecular chemical transformations. These processes require specific raw ingredients and reactions to create the final building materials. These extreme edge cases, like massive cargo ships navigating global trade routes, require specialized interventions. That means deploying green hydrogen, a clean fuel produced by splitting water with renewable electricity, along with carbon capture and sustainable synthetic fuels. These heavy sectors are the final, most complex gears in the decarbonization machine. They require targeted engineering rather than simple consumer-level replacements. When we put the pieces together, we get a complete blueprint. We build a low-carbon grid to power electric infrastructure, patch the methane leaks to slow short-term warming, and deploy specialized fuels for heavy industry. There is no singular savior technology coming to do all of this for us. The remaining barrier is systemic speed. We have to navigate the politics, clear the permitting bottlenecks, and organize the financing to build this exact blueprint. Progress requires an aggressive overhaul of the world's physical defaults. We need systems that make a carbon-neutral life the inevitable result of existing infrastructure. We already possess the exact knowledge required to stabilize the planet's temperature. The only remaining task is rapid execution.